So here we have the series sum n equals 1 to infinity 2 to the n divided by n factorial. Now let's remind us what n factorial is. Right? N factorial is going to be the product 1 times 2 times 3 times 4, etc., all the way up to we get an n minus 1 and then times n. Right? So for example, 5 factorial is 1 times 2 times 3 times 4 times 5. So that should be, let's see, here we get 6. 6 times 4 is going to be 24, and then times 5 gives me 120. And so 5 factorial is 120. Sometimes it'll be useful to think of n factorial as being characterized by the fact that n factorial is n times the quantity n minus 1 factorial. Okay, I've put a lot of brackets there, but usually we think of the factorial as applying just to the previous expression. So that outer set of brackets were a little bit optional. We could have written this as n times n minus 1 factorial. Okay, so let's attack this using the ratio test. Right, so here we have this quantity r, which is going to be the limit as n goes to infinity. We're going to take the limit of an plus 1 divided by an. So an plus 1 is going to be 2 to the n plus 1, and we divide by n plus 1 factorial. And we're going to divide this thing by the nth term, so that's 2 to the n over n factorial. Now, I hate dividing fractions, so we're just going to remember that dividing by a fraction is the same as multiplying by the reciprocal of the fraction. And so this is now the limit as n goes to infinity of, here we get 2 to the n plus 1 over n plus 1 factorial, and then we're going to get multiplied by n factorial over 2 to the n. So we get limit as n goes to infinity, and now we're going to take these terms here. We're going to say that this guy and that guy, right, that's 2 to the n plus 1 divided by 2 to the n. Well, that simplifies to give us 2. And then over here, we have an n factorial divided by n plus 1 factorial. So now we're going to use that fact right there in order to simplify this as being 1 divided by n plus 1. And so I'm going to write this as 1 over n plus 1 over here. So this is the limit as n goes to infinity of 2 over n plus 1, which gives me 0, and 0 is conveniently less than 1, so the series converges.